Hi, today we're going to talk about Archimedes' principle and how did Archimedes came up with the idea of his principle that is very well known nowadays. We will also get to define what density is. And as a final topic, we will also learn plenty about manometric method. So without that further ado, let's get into it. So, our story takes place in ancient Greece in a little more than 2,000 years ago, when King Hero II of Syracuse decided one day that he wanted a new crown. Maybe this was because his old crown gone out of style or something. So he took some gold, pure gold that he owned, and he took the gold pieces down to the goldsmith and said to him that he should make him a new crown out of the gold that he had given. And the goldsmith took the gold and made a crown out of it. Several days later, the goldsmith then delivers a beautiful new crown that the king immediately loved. He thought that he looked brilliant in his new crown. However, for some reasons, the king gets suspicious about the goldsmith. He thinks that the goldsmith might have swindled him. He thinks that the goldsmith might have cheated on him. He thinks that the goldsmith took some of the gold for himself and he kept it. And then he replaced the gold with a cheaper metal, say like silver. And then took the gold and silver and melted it down and mix it together to make it as the king's new crown. So that the crown would kinda look like gold, but it wouldn't be pure gold because of the silver that had been mixed with it. The king is really getting suspicious and he needs to know whether the crown is made out of pure gold or if there is something sort of cheaper metal mixed in with it. So, in result, he calls on Archimedes, who is an incredibly well-known scientist, inventor, engineer, and mathematician in ancient Greece, a great solver of problems. In an instant, Archimedes is summoned to the royal court, and King Hero II said to him, I have this crown. I am not sure if it's made out of pure gold. The goldsmith might have cheated on me. How can we determine whether this is a pure gold? Archimedes, luckily, was a very sharp guy, thinks about this for a while, and he came up with the idea of density. He's like, we will figure it out whether this is a pure gold by using density. So density asks how much does it weigh? Its mass. When a material fills a certain amount of space, its volume. So for example, I have here a bowl of chips. The chips has very low density. They're filling a certain amount of space, but it doesn't weigh that much because the chips itself has a very low density. But for example, if we have a bowl of coins, it's much heavy. It would be much heavier since metal have much density. It turns out that the materials have distinctive densities, therefore you can use densities to tell the difference between materials. Even in metals, they have their own designated densities. Here's a list of metal from aluminum, which has lowest density, to platinum, which has the highest density in the list. Aluminum is of course not that heavy, but on the other hand, platinum would be really heavy because this metal is really dense. Now, density is something that we can measure. There's a number associated with it. So Archimedes realizes that he can measure the density of the metal that makes the crown, and then he can figure it out what the number is and see if it matches up with the gold's density. If it's 19.32, okay, then it is probably a gold, pure gold. But if the number is, say for example, lower than the density, say like the silver, he could say that the crown is not pure gold, but rather it has some another cheaper metal that had been mixed in with it. So in order to come up with this number of density, Archimedes has to weigh the crown. He has to determine the mass divided by the volume, which is the space it takes up. Get the density and see if it's actually gold. All he had to do is put the crown into a scale. However, the volume though is a problem because the crown has no definite shape. See? It has an irregular shape. If he could only melt the crown and turn it into if he could only make this crown melt, then turn it into something cube like this, he could just multiply the length, width, and the height, and then multiply them all together and figure it out with some mathematical equation to determine the volume. But that cannot be done because it will destroy the crown, and the king might be really furious about it. So he keeps thinking and thinking, how can I get the volume for the crown when I can reshape it into an easy shape like this and use a mathematics to solve for the volume? He just keeps thinking and thinking until he's about to give up. So he decided to take a bath in order to refresh things up and take a breath from his work. He draws a bath of water, poured it in his bathtub, and it looks like this. And he gets into the bathtub. Now, as he is submerged into the water, he noticed that the level of the water rises up as he gets into the bathtub. See? And there, he makes a tremendous discovery. He realized that as he gets into the bathtub, his body is pushing the water away, and that his body takes up. All he had to do is to look at how much the water rose when the crown will be submerged into the water. As you can see, this is what we almost do all the time in the lab. Say for example, on what we did on our experiment, we have a metal sphere. This, and we want to measure the volume of the metal sphere. We can just use a simple math equation to calculate the volume of it, but we can do is we can put it in water, then measure. Say that the level of water in a graduated cylinder is 150 milliliters. And then, when we submerge the metal sphere on the graduated cylinder, the level of the water rose up and it went at 200 milliliters. And that we can conclude that the volume of the metal sphere is 50 milliliters. So Archimedes, upon realizing that he had made an amazing discovery, he quickly jumped out of the bath. Didn't even have time to put clothes on because of excitement. And he ran through the streets of Syracuse shouting, Eureka! I found it! Which is a Greek word that means I found it. I figured it out. It finally makes sense now. So people use the word Eureka now whenever they have figured something out. Archimedes finally figured it out how to measure the volume of the crown, so he goes back to the king. They weighed the crown and determined its volume, and as a result, they found out that the density is too low, which means that the goldsmith took some of the gold for himself and mixed it in another cheaper metal, say for example than silver, as I have said before. Based on researches, they didn't know what happened to the goldsmith, but I'm pretty sure that the king wasn't happy when he discovered that the goldsmith had cheated on him. It just means that the goldsmith wasn't paying respect to the king, Hero II of Syracuse. It's a great story and it's highly connected with our topic, density. I hope you have understood well how did Archimedes came up with density and how does density work. So let's move on how we conducted our experiment regarding this. Thank you.
Good morning, ma'am, and also the people who's watching this video reporting presentation. And I'm going to present to you our first activity, experiment 1, which is the Archimedes method. First, we launch the data studio using the laptop and make it digits and increase its precision to decimal places. Then, second, we get the mass of the three metal spheres, which is black, gold, and silver. And we've noticed that they have different mass weight. Third is to get the mass and the volume of the water. We use this quadrated cylinder with half full of water. We use to submerge the metals from the water, and we've noticed that when we submerge the metals into water, the volume will increase and the mass of the metal sphere will be lost in its original weight. So, therefore, we calculate specific gravity and the density and compare its value. That's all. Thank you.
Manometric method has been described for measurement of the activity of sea air, while chill is infinite. The method depends on displacement of carbon dioxide from a bicarbonate carbon dioxide buffered medium by the phosphorylcholine liberated during the enzyme hydrolysis. Initially, manometric methods have been only employed in biochemistry, mainly for scientific investigations on the respiration of animals and plants, the assimilation of plants, processes of fermentation, etc. These methods soon turned out to be suitable for resolving practical problems of analysis and questions occurring in the industry. As well, they furthermore can be utilized in the study of processes not entailing the formation of gases. Dilatometry, the versatility of manometric methods are demonstrated in practical examples.
Good evening, and now we will show you how we set up our experiment using the manometer method. Our objective here is that we must compute the density of the oil and its specific gravity. So let's get started. So first, we use the small graduated cylinder in order for us to measure the colored water or the H2O to 2 ml. Then after it, the second one is pour the 2 ml colored water or H2O into the YouTube manometer. After that, add few drops of oil until it reaches the middle bottom part of the YouTube manometer. use the aspirator in case bubbles appear, and use it to push the oil to go through inside the middle part of the YouTube manometer. The fourth step is now added, as the two liquids each equilibrium measures heights of the liquids in order for us to see what is measured inside the YouTube manometer. After that, compute for the intensity of oil, also its specific gravity. And the last, compare the computed values to the true values determine errors. That's it. That's the last one. See you guys later.